Exercise 36, we've seen something similar to this. We're being asked to describe the error in solving this inequality. So what is the error that they made when they did this work? Well, like I spoke with you earlier, you can do one of two things. You can either reason through all four of these and check to see if any of those seem to be the error. Or you could also solve it out yourself, and solving it out yourself, you'll be able to determine how yours looks different from theirs, and that's assuming that you did yours correctly. So let's go ahead and solve this out together. This is negative 3 times m is greater than or equal to 9. I've got a negative 3 next to the m. I want to get rid of that negative 3, turn it into a 1. You can turn any number into 1 by putting it over itself. And so that means I'm going to divide both sides by negative 3. When I divide both sides by negative 3, on this left side, I'm going to end up with a positive 1m. And then on the right side, 9 divided by 3 is 3. Positive divided by negative is a negative 3. And then because I divided by a negative 3, this 9 went from being positive to now being negative. And so that means that we are going to need to flip the sign between these two expressions. And this is going to now be a less than or equal to. So m is less than or equal to 3. So now, using that information that I just gave you, the one that we worked out together, hopefully you knew those steps already, we are going to compare our work to the work in exercise 36 and describe what their error was, what they did differently. So hopefully I did that right for you. And then after that, you're going to correct the error, just like the last one. You're going to input everything that should be the correct steps. All right, exercise 37. This is one of the word problems, so let's go ahead and just reason through this together. It is currently 0 degrees outside. The temperature is dropping 2.5 or 2.5 degrees every hour. Identify an inequality that represents the number of hours that must pass for the temperature to drop below negative 20. So let's highlight some of our important information. It's currently 0 degrees outside. It's dropping 2.5 degrees Celsius every hour. Identify an inequality that represents the number of hours. There's another number of hours that must pass for the temperature to drop below negative 20. And then looking at our options, I see that they all have either a 20, which is going to be positive or negative, and then they also have a 2.5 being multiplied by the x. So then you got to ask yourself, what does x represent in all of these inequalities? Well, we're identifying an inequality that represents the number of hours that must pass for the temperature to drop below negative 20. So that means that x must represent number of hours passed. And then why are we multiplying in these inequalities? So we're kind of working backwards here, as you can see. Why are we multiplying that x, the number of hours, by a 2.5? Well, that 2.5 comes from up here, where the temperature is dropping 2.5 every hour. And then I see that some of these are negative while others are positive. So what's the difference between having a positive and a negative multiplied by this x? Well, that comes in this keyword dropping. So the temperature is dropping 2.5 every hour, which is different from the temperature increasing, getting hotter 2.5 every hour. So if the temperature is dropping, that's kind of like going down, it kind of makes sense that we would think about this as a negative rate. So it's a negative 2.5 degrees Celsius every hour, whereas increasing 2.5 every hour would be a positive 2.5 degrees Celsius per hour. And so because this is dropping, we're going to want to make our degrees Celsius 2.5 degrees Celsius per hour a negative, because that represents that it's dropping, whereas a positive would represent that it was increasing. And then now the next thing we need to ask ourselves is, what's going on with these 20s? Why are some negative, why are some positive? Well, those 20s, as I compare it to over here, must represent the degrees that we want to drop below. We want to drop below negative 20 degrees because we want the temperature, we want to find the number of hours that must pass for the temperature to drop below negative 20. So out of these 20s, between the positive and the negatives, I'm going to choose the one that has a negative. And then just through those reasonings alone, because we chose, just through that reasoning alone, I see that the only one of these four inequalities that fits the descriptions of what I've been talking about, that's a negative rate multiplied by x, the number of hours, and the negative 20, that represents the negative 20 degrees Celsius, is the first inequality. So that in itself gives me the answer, and I didn't have to reason through the whole problem. So that's just kind of some test-taking strategies that you can take away from this problem, is reasoning through these problems. And then this third option just had absolutely nothing there for us, because it was a positive 20 and it was a positive rate, positive 2 5/10, and neither of those really fit the description of this word problem. And then also, just before we finish this one up, since I've already given you the answer, I also want you to see that this inequality symbol is the less than, because when we multiply the negative 2 5/10 times the number of hours times x, that gives us the current temperature, and we want to determine how many hours have to pass for the current temperature to be less than negative 20 degrees. That's what we are being asked here, is we want to drop below negative 20. So that means we want to be less than negative 20. So that's why it is a less than sign instead of a greater than sign. And it's not a less than or equal to, because we don't want to be at negative 20, we want to be below negative 20. The very last thing you're going to do is you're going to determine the solution of that inequality. I'm going to let you do that by yourself. Just keep in mind what happens when you divide by a negative number.